All right, everyone. Welcome to LoFi 29. Uh, we're coming up on our 100 speaker marker. So this is really exciting to me. This community has been going strong for close to 3 years now, and it's made possible because of lovely speakers like you all and our wonderful community members. Uh, and also our sponsors. Lo-Fi is sponsored by Vela, Electric Sequel, Jazz, and Zero. Uh, this it has helped kind of cover our bills and make this a sustainable thing to keep doing. Today, our first speaker is Jan, and if you haven't caught one of his talks, he's been around the block for a little while, and I have learned that he has coined the offline first word, which is exciting. I like to claim that I invented the lo-fi name for local first, but it was a collaboration with three people. I'll tell you the story later in the Q&A section. All right, over to you, Jan.
All right, welcome everyone. If my screen is a little bit blurry, it'll come in a second, or should come in a second. Welcome to my talk about how to think anything in 15 minutes. This gives me sweats trying to explain it all in 15 minutes. Just as a heads up, there's a lot of details I'm going to gloss over, and there's resources in the end where you can read up on all the details of all of that
Nice.
later on. Why should you be interested in this? You might be building a distributed system right now. If you're building a website with a front end and a backend API, it's a distributed system. If you build a native app with a backend API, it's a distributed system. If you have a backend service and a separate database service, it's a distributed system. And basically, as soon as you have two computing devices that communicate over a network, you have a distributed system. Switching gears real quick, any sufficiently complicated program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of common Lisp, commonly known as Greenspun's 10th rule about how to architect software properly. And you should use Lisp from the get-go because then you solve a lot of problems you don't have to solve a lot of problems. I'm adopting this as any sufficiently complicated distributed systems program contains an ad hoc, informally specified, bug-ridden, slow implementation of half a sync engine. What are those distributed systems issues? Can we talk to the other side? Can the other side talk to us? Can we do it in a round trip, like have a communication acknowledged by the other side? Is an object that is on our side the same entity as the object on the other side? Um, is that object on our side an older or newer version as an object on the other side? Other issues include how do we deal with situations when message sending from or to the other side is interrupted part way? And if we resume from this failure, how to avoid resending duplicate data and how to deal with conflicts. So why are we talking about distributed systems here? Another step back. Why synchronization at all? When programming, we all learn about loops like this. We have a manually managed iterator, the I variable here. We have a length that we can iterate over. We increment that, and then we have our list item and can do stuff to it. This is very explicit, error prone, very low level, and there's better options. Modern versions of this include functional list map with a callback function that just gives you the item, or a for each with a key, or a for each with a value that lets you iterate over things without having to worry about how long is the things that I want to iterate over at all. So this is no off by one errors here, has the same flexibility as the previous solutions, and it's a higher level iteration primitive that makes code safer. Um, in this case, even list can be a dynamic object, like a database result set, doesn't have to be a static array. So this is an abstraction that you find in all modern code. You shouldn't write for loops by hand anymore. I hope if folks are new here, you probably hopefully have never seen the first example that I showed. But why am I doing this example? Why am I running through this example? I believe synchronization or sync is the modern abstraction for dealing distributed systems or dealing with distributed systems on a higher level. It is the thing that makes our code safer, that solves problems for us. Um, the problems that I highlighted in the beginning for us. It's less error prone. Basics are covered. We don't have to deal with connection handling, object identification, revision handling, smart resume recover from random disconnects, and so on and so on. So how do we actually do it? Um, um, the notion of conflicts is a big question, and it forms roughly the two schools of synchronization. Um, the what I call object sync versus CRDTs. Object sync is mostly like Git, makes conflicts first class. You've all seen this like conflict markers in Git source code that you have to resolve. They are guaranteed to not compile, so you have to deal with them. But the upside is they allow generic CRUD operations. Like you don't have to use a special Git editor that understands the Git. You just like edit files as you would always normally edit files, and everybody can do this in a distributed fashion. And Git makes it all work as long as you obey these conflict markers. Um, that's pretty good. And CRDTs on the other side, that very cleverly try to avoid conflicts, but that limits some of the expressiveness inside what we can, like how we can model our data, produces a relatively tight coupling of the application logic and the sync model. If you're very, very smart, you can get out of this, but that then adds API complexity a little bit, and also cannot resolve 100% of all conflict scenarios. But I'm not here. Sorry, at the very theoretical end, both of these solutions are doing roughly the same thing in terms of outcome. They're not as different as they might seem. And I'm not saying one is better than the other. They have their strengths and weaknesses. I have built systems where I would say that was a bad idea doing it as object sync. We should have done it in CRDT or vice versa. I'm very open about like um, that there is no silver bullet for any of this. But since the CRDTs are kind of the fundament, like the founding of the local first movement, I want to put some light on the object sync model just to like teach you all a little bit what we've been doing the past like 15 years, building offline apps with object sync or Git style things. Cool. So object sync. Ingredients. We need an ID to identify objects in our system. I recommend you use a string that's a UUID. There's some tweaks you can do to this with like prefixes and postfixes for some like implementation specific optimizations, but you shouldn't be using an auto increment integer like you get automatically from a bunch of databases. The problem is if you have two distinct computers that can't talk to each other and they cannot agree what the next valid integer is. So they need to be able, like, either they're able to independently choose what the next version is, or they have to talk to each other. But if they can't talk to each other because of a networking issue, then you have basically a global lock on your system. So try to avoid auto increments when those numbers or these integers have to be valid across a distributed system. That becomes important shortly. You need two indexes on your data structure. First is a list of our IDs, or string ID or UUIDs. We call this the by ID index. It's just the one that you need to look up any object. So think select ID from table or select star from table, like to get all of the objects in your store, usually sorted by the ID. Sometimes that's important, sometimes that's less important. Um, the more interesting thing is the secondary index called by sequence is a list of integers that are actually auto increment. I'll explain why in a second. And this is an index that lists all objects in the order that they were updated or stored in your local store. So you can say things like you can say, show me the order of objects in as they were inserted into my store. Think git log when you type git log on your computer, or select unique star from table order by last updated. I know you all speak SQL fluently, so you immediately know what this is. Don't worry too much. You can look this up. Git log is the better. It's just an update log, but it allows you to quickly search for, hey, just give me the last 5 changes or the first 5 changes or any range in the middle, and to get that responded real quick. The sequence in here can be auto increment because it's only ever valid on a single machine. Only one machine has to say, hey, there's been a change to my local store. I'm updating the integer. I'm updating the integer. So that can actually be an auto increment. And we can store those in checkpoints in all the partners that do the synchronization with each other. So if A replicate or synchronizes with B, all up until sequence say 5, then next time they synchronize, you can say, give me all the changes that happened since sequence 5, and then that by sequence index gives you just the delta of the objects that you want to be syncing now. So you can always smartly resume, either if there was nothing else to synchronize, or if you were interrupted halfway through. For For this index, it's important. That's why it's a unique star. It supersedes insert, like updates supersede inserts. That means each object there's in there only once, and deletes are just updates, and you need to put in a special marker that says deleted true, so you can synchronize deletes. So if you delete something on one peer, it gets synced to the other peers as well. Um, that's basically already it. There's just one more ingredient, which is like versioning or revisioning. I never know which one to choose here. For this, you need a revision identifier. We call this rev. There's a bunch of options. You could use an integer, but there's similar issues to auto increment. If you make make a change to the same object on two different computers, like choosing which one's next one without coordination isn't possible again, or you run into conflicts real quick, which is annoying. You can use timestamps, but those require perfect time sync. Even if you're single, like if you have like just one person to-do list sync, you can still run into trouble with timestamps because these can be hilariously out of date. Google and Amazon and Azure do very smart things to work around this. If you want to learn more about this, look into the Spanner papers from Google. They're very, very fun, but you don't have millions of dollars just to keep time. So try not to rely on those. There's also a bunch of falsehoods programmers believe about time and the sequel. These are linked in the slides, and they're very, very fun to read through. So have fun and laughing about what's happening there. An improved version of timestamps is this thing called vector clocks. It's logical clocks. It's not actually time. There is an issue that any change is in your revision that's a potential conflict, and even if you make the same change on both sides, it will be treated as a conflict that you then have to resolve. So it's kind of annoying in that ways. In that case. So what I suggest you do for revision identifiers is use content addressable hashes. You just hash the contents of the current version of your document, and that hash is then the object identifier. So it's a string hash type. And if you keep that in a list, you know which comes first, which comes after. So if in this case, like C comes after B, so you can sort it in there. And then actually keep it in a list of lists or a tree. So if you have a conflict, store it in two leaves here, so you know revision E is now in conflict, and then you can do stuff with it. In opposition to Git, we don't put in like an invalid marker here because that means you would like get rendering errors in your app. That's silly. You just pick one of those with a smart algorithm, so you still have a consistent view of all the apps, but you still have a conflict marker, so you can resolve it. And then you can, this is a tiny tree, but imagine you can have any number of conflicts in there. If you have like multiplayer things, you recurse through that tree to resolve all the conflicts. So you can back into a list, and that's a lot easier to handle and reason about and all that jazz. So here's an example. You have a server and a client. We're syncing stories on the top left. I'm not sure if you can see my my pointer here. You have stories 1, 2, 3, 4, 5, and updates to those. We store those updates in an update sec and with the story ID that belongs to that. And the client currently has no stories and has a like checkpoint or high watermark of 0. Says, hey, server, please give me all the stories since 0. And the update sequence will tell us, or update sequence index will tell us, well, the stories 1, 2, 3, 4, 5 will have to be synced over. Client does this and stores the high watermark 5 here. And the next time it asks, hey, give me all the stories that happened since 5, which on the server in the meantime we have updated story number 3, which is reflected down here in the update sequence. We have 1, 2, 5, 4, 3 is now the order in our update sequence with the update sequence 7. So we only have to sync 3 star star over here, stored here. Sorry about the overlap. So this is how we get to efficient delta updates on the object level. And then just to go through this again in text, there's 2 devices, A and B. You want to sync data from A to B. You read the high watermark checkpoints from both devices if they exist. You start reading the update sequence from A, from the recorded high watermark, or from the beginning if none exists. And for each ID and version pair that you get from this query, you check, is it a delete? If yes, store the delete locally. We'll look at that further. And B, if that ID version pair is already locally on B, if not, we'll fetch it from A and store it on B. And then we store the high watermark on the current update sequence of A and B. And if we do have it, we don't have to do anything. And then locally storing is relatively simple. We check the version list to see if the new version is the direct successor of the currently latest version on B, and if yes, we'll just add we just add it to the list, and if not, we create a tree in the conflict and then move on. And that's it. You can also just use CouchDB and PouchDB because all I've done is just explain how they work. But for me, it's very important to teach that you can do this yourself. There's no magic in there, and you can make different choices in all of these things. So you can go and say, well, this model is really cool, but vector clocks actually solve a problem that I have better than the content addressable hashes. And then you just switch this out, and I give you all the primitives to build your own sync engine with this. But if you don't want to deal with any of this, the big benefit of using an object sync system is, again, you have your standard CRUD API, and sync happens like on the side and magically for you, as long as you're prepared to handle a bunch of conflicts. That'll be a separate talk at some point about how to do all this. And there's some automation in there in the end. The end result doesn't look much different from what a CRDT solution looks like, which I claim with a lot less code, but other people disagree. But that's why we have a lively debate here in the community. Further reading here is how to sync anything. Was a like distillation of a 4-part blog series that we have on our blog. Link to the first one is in here. We'll share the slides later, of course. And then that's all extrapolated from the CouchDB replication protocol, which is our RFC style. This is what goes over the wire kind of stuff. And if you want to learn more about Couch and Pouch, they have websites. You can look at those. Thank you very much. I hope I am in time.
That was that was awesome. Yeah, and wonderful talk. And I think a whole series is definitely required. This will give me like CRDT school vibes, but maybe it's called conflict school. Uh, if you stop sharing, I can get Mauve on next. All right, there's like one question on the chat if you want to kind of tackle that. Next, we have Mauve. Everybody knows they've been around sharing a lot of the learnings from the Agrigore browser and all the P2P stuff. Big fan. And I will hand it over to them to kick us off.
Thanks. Let me just set up my screen. Cool. Yeah. So thanks for having me. My name is Mauve Signweaver. My pronouns are they, them, or it, its, and I'm a decentralized software consultant currently
Mauve,
working for
sorry,
Awana
it
Digital.
hasn't loaded on my end yet.
Oh,
This
should
might
I
be
restart?
tricky. Let me try jumping
Here,
out
one
and
sec.
coming
I'm going to
back in.
kick my roommates off the Wi-Fi.
Uh, it hasn't loaded on my end. Uh, could you try stop sharing and resharing? Yeah, I'm the only one who's streaming and recording. So let's if only Discord had some solid P2P stuff. Uh, if you start sharing, we can see if it has worked. Apologies for the technical difficulties. Yeah, and on sound check, which we always do before we start these things. Okay. Uh, Alex, why don't you take over? Let me just quickly introduce you. All right, folks, if you caught the Hacker News post on lies I was told about CRDTs, you've kind of got some of the gist. Alex, you're sharing your Discord window right now. I don't know if that's intentional, but he's an infrastructure engineer ready to skill us. Over to you. Okay. It's up to you. Yeah, let's do whatever is working.
Good. So I can't I don't have the Discord window open, so if there are questions or anything, you'll have to physically shout them out. I'm gonna talk about building a truly offline first collaborative text editing product. Okay, so I assume you can hear my screen. If there's any difficulties or anything like that, just let me know.
That's working great.
So really quick, who am I? I'm mostly an infrastructure engineer. I've worked at really big companies and really, really tiny companies on all kinds of things, production real-time systems, production compilers, Kubernetes stuff, everything from millions of queries per second to startups with basically no traffic at all. I assume I am talking to the LoFi community. I will assume some passing familiarity with things like operational transforms and CRDTs and so on. I'm not going to go into the details of those, but I'm happy to answer questions or talk about them after the talk if people are confused. Also, we only have 20 minutes, so I'm going to skip like a ton of stuff that I would normally go into detail on. Happy to take questions or comments after or catch up on Discord or whatever works for people. So my goal in this talk, my motivation is mostly that I found it when we started building the product that I'm working on now. I found it very hard to get practical advice about how to actually build a real-time collaborative, truly offline first text editor. So I messed up a sentence here, but I've structured this mostly as a series of surprises that we encountered while we were building this product. I think the only thing that I want to say at the outset is that none of what I'm saying is gospel. I'm just presenting this as our experience. If you have a different product context, I'm sure that you will end up with different results. But just mentally, I think you should prepend everything that I say with "in our experience" because none of I'm not trying to like make grand pronouncements about CRDTs or collaborative editing or anything like that. I'm just trying to say what we found as we were trying to build out this product. So what did we build? I think this is important to cover really quickly. This is not a product pitch, but I think to understand the decisions that we made, it is kind of important that you understand roughly the product that we were trying to build. Our idea was to build a modern rich text editor,
Alex, have you
basically.
started sharing something? We still only see the Discord.
Oh, I'm sorry. I thought I was sharing my slides. So I think I have no choice but to uh, but to unshare and then reshare.
Yeah.
Uh,
It's Discord again, but at least we see you moving the window and stuff.
I think that I'm not sure how. Okay, so just to confirm, I know we did do sound check, so this is like I feel like I'm on like crazy pills or something, but when I share, it gives me the option to share this window or share all application windows. And I'm choosing all application windows, but it's only sharing the Discord.
Do you have two monitors maybe?
No,
I'm not clear.
just one monitor.
Okay, give it another shot. Let's see. Okay, try minimizing the Discord. We still only see Discord. Command H. Yeah, now the screen is blank. So I think maybe make selection and pick the slides.
Okay. So make selection, and then I only see share this window and share all application windows. Should I see something else?
Yeah, maybe I can.
Okay. I will screenshot what I'm seeing.
Okay.
I apologize for this. We did do this in sound check, so
Don't worry about it. So when you
yeah.
click make selections, share this window is on the highlighted view. If you tab in command tab into the slides and hover over it, the share window dialog will switch to that one. Discord made this change or Apple made this change. I don't know. It doesn't. It's not fun. But you just have to sort of
Oh, got it. Okay.
take that dialog box where you want to go.
How about this?
Yay, we're there.
Okay. Oh my goodness. Okay. All right. Okay. So I'm just gonna go through this super quick again. Right. So I introduced myself. I'm an infrastructure engineer. I've worked on a bunch of stuff. I am gonna sort of assume basic familiarity with at least the collaborative editing buzzwords like operational transforms and CRDTs. I won't explain that, but I'm super happy to talk about it after. Motivations. I just want to share. I'm trying to start the dialogue that I wish that I had when we started working on this product, which is focused on very practical advice about how to build systems. I think no matter what technologies you choose, there are going to be trade-offs. And the thing that I wished for when I started this process is for people to tell me clearly what was going to get traded off under different technical choices. So I'm just going to talk about our experience, our technical choices, and what got traded, like what we think we traded off, and what our experience was doing that trade-off. Nothing here should be interpreted as immutable truth. I'm just talking about our experience, not trying to talk generally about CRDTs or anything like that. Okay, so not a product pitch, but I'm going to talk a little bit about what we do, just because it's important to understand our product context in order to understand why we made the trade-offs that we made. I'm a little bit scared to share both this window and also a window demonstrating the product, so you'll have to settle for me saying words at you that describe the product. Apologies for that, but the product is basically a text editor. Our goal is to be a modern, collaborative, rich text editor like Google Docs or Notion. So you have buttons, tables, built-in databases, that kind of thing. But, and this is the important part, it's very important to us that all documents are plain old markdown files stored on your local device storage in Git repositories, right? So private by default, we don't have access to your data by default. If you make it collaborative, we will sync it via server, but it's not like by default, everything is just plain old markdown and JavaScript files on your disk, right? So I would show this, hopefully, hopefully that's clear, but I think that's probably good enough to talk about the distributed systems parts anyway. So our architecture, I'll just quickly go through this. This isn't so much important, but just so you know, we're built on top of React Prosemir, which is a descendant of the Prosemir implementation that the New York Times wrote for their internal text editor, which I understand is called Oak. I've not worked at the New York Times, so I don't know that firsthand. We are built on top of a startup called Reboot.dev, which is kind of like a souped up Cloudflare durable objects. I'll talk about this in a second. And then for editor transaction reconciliation, we're built on a library called Prosmere Collab Commit. I'll talk about that later as well. So I just want to talk really quick about things that we care about, just to I think it's important for us to say what our assumptions are and like why we care about the things that we care about, because it makes some of our choices clearer. So number one precept that we have, I think all UX is derived from this single principle, which is that users should be able to predict what happens to their data. I know that sounds simple, but it's actually harder to achieve than you might think. We will get into this more later, but my experience is that the closer to real time you are, the more predictive power users generally have over their data, that when their data is like text documents. The further away you get, the more offline you get, the less predictive power they have. And that for us is going to be important for one of the trade-offs that we make. But that's very important to us. It's very important that people have the ability to sort of meter how their data changes and like what happens to that data, and be able to have some sense of what's going to happen to their data as a result of those choices. We care a lot about optimistic updates. So typing speed should be independent of network speed. Edit should be immediately reflected in the core editor itself, and then that should be reconciled if necessary with others if you're syncing to some remote. We're targeting for the live sync use case, we're targeting like less than 100 milliseconds round trip for 50 writers, so tens of writers, thousands of readers. Just as a ballpark, that's the kind of latency that we are targeting for the live collab case. For the async collab case, where you're operating through Git, different story. I'm not going to talk so much about that this time. If you do want arbitrary long forks, usually that's via Git, but if I have time, I'll talk about what our plan is for core collab. We would like the algorithm to support sort of arbitrary long forks as well. There's some subtlety in this. Okay, so I'll say at the outset, we did not use CRDTs for this, and we mostly don't regret it. I'm going to mostly talk about why that is. Not saying you shouldn't use CRDTs, not saying CRDTs are bad, just saying what we chose, what the trade-offs were, and what we found as a result of this. So myths and surprises section, I think this is going to be sort of the meat of the presentation. And once again, just our experience, not trying to bury anybody's work or anything like that. Just remember that as I say this stuff, preface everything with, this is our experience. Our experience was X. Okay, so surprise one. I want to start with like an example of going back to the question of like users should be able to predict what happens to their data. I just want to start here with an example. So like, let's say I have a document, the color of pomegranates, and you have two editors who are offline. Okay, one of them changes the spelling of color to the British U, so color with a U. And then one other person deletes the whole document, and then they are both to come online. Okay, so what should happen in this case? I think there are a lot of reasonable answers. What actually happens under every collaborative editing library that I have tested, including Share.js, which is operational transforms, YJS, which is CRDTs, Paratext, AutoMerge, all of these sort of produce the same result, which is they produce a document with just the letter U. So I think that is really interesting. Like my takeaway from this, everybody can take away their own thing. My takeaway from this is that collaborative editing in the offline case on direct editing conflicts, which is to say you have two people offline editing the exact same text, coming back online and having to reconcile those, I don't think that's purely an algorithms problem. Okay, and the reason I think that is because users viewed, when we put these and other direct editing conflict reconciliations in front of users and we test the results, users say that they view this as data corruption. They are confused about what happened to their data. They think that the software has malfunctioned, and they are not happy about it. So not saying that this can't work under any circumstances. Lots of technologies, lots of products use CRDTs for lots of stuff. That's totally fine. For our context, where users are live editing documents, this is something that we have to be wary of. We have to design our user experience around the idea that users are probably going to interpret direct editing conflicts in our product context as data corruption. So, you might make different choices, end up with different results, but that's what we found for our product context. And so for me, there's a couple of surprises here, which I wish somebody had told me ahead of time. One is, in our experience, right? In our experience, It was surprising to me that users empirically view the results of standard CRDT libraries in particular as data corruption. My belief going into this was that there was like a right way to do reconciliation in the offline case, and that this would sort of magically get taken care of. I don't believe that's true at this point. What I think is true is that you can choose a product context and experience where conflicts are less likely, and that could produce a good set of outcomes for your product. You could maybe make other trade-offs, but for our product context, I think this is kind of an immutable truth that we're going to have to work around, and that's one of the reasons why we base the offline stuff mostly around Git. Okay, so that's surprise one. Surprise two, I think what this means to me for our product is that it's not sufficient for entirely offline collaborative editing. I think you're going to need something more. I think a lot of people are working on stuff like this. I know the Ink and Switch people are working on better tooling for having CRDTs, you know, like produce logs of edits that are richer than what you would have in Git. We haven't done something like that yet. I'm excited for that line of research, but for for now, what I'm prepared to conclude is that it's not sufficient for it's not alone in itself sufficient in our case for entirely offline collaborative editing. So I would say we were surprised by that. Maybe in your product context, you will find something different. So surprise three, operational transforms and CRDTs we found are not actually required for reconciling long latency changes. So that is to say, if I want to produce a collaborative text editing product with, you know, instant optimistic updates, and then I want to automatically reconcile them on some arbitrary time frame, I don't actually need CRDTs for that. In fact, what we found, well, actually, sorry, you don't actually need CRDTs for that. So that's the claim that I'm going to make, and I'm going to justify it. But before I justify it, I want to say asterisk, in the case where you have a central server, right, which is what we have, this is an assumption that I'm making in this section. For a central server, if you have a central server, my claim is basically that you can reconcile changes using a variety of means, you know, Couchbase, that kind of thing, or our approach. But if you're doing something like peer-to-peer, I have no idea. There are lots of people who do peer-to-peer stuff. I'm sure that they have opinions that are helpful, but I don't have much to say about that because I don't really know that much about that case. What we found when we were operating in this setting where we have like a single server, a single source of truth, which is mediating conflicts between people, is that every collaboration library that works with a central server on rich text documents supports sort of arbitrarily long disconnects, which I think means that you can choose essentially any of them to get optimistic updates. So that to us means Prosmir Collab, Prosmir Collab Commit, YJS Paratext, even the ones that require a central server. I know YJS and Paratext, you can do peer-to-peer stuff, but even the ones that require a central server, we found produce approximately the same results as, like, let's say YJS. So what do I mean by that? Let's take an example of Prosmir Collab. Prosmir Collab is, you know, roughly operational transformations without the O, right? So it's not so much important how the conflict resolution works, but the way that I think of all of these libraries, I know this is kind of technically not true, but if you go back to the direct editing conflict case, my summary of the direct editing conflict surprise is that absent more information, absent being able to like go talk to the person down the hall about a change that they made to the document, what you're going to find is that the algorithms essentially have to choose somewhat randomly between two conflicts, if you have two conflicts, they have to essentially choose one or both of those conflicts randomly, because they don't have enough information to know what you're really trying to do. Prosmir Collab also handles conflicts basically randomly. Right? If you give it two conflicting edits, it will give you essentially a random, it happens to be the same random conflict often as YJS actually, but it doesn't have the mechanical complexity it doesn't have all the mechanical complexities of YJS. So basically the way it works is that the server keeps a canonical integer version. You submit your changes with your last known version, and then if the local version is different, you rebase those changes from the server. You rebase your changes on top of the new base from the server, and then you resubmit those changes. There's a lot of downsides to this. The main one is that it's chatty and it can starve slow network editors. But this is improved by other things. The main thing that I'm trying to show here is that this is not operational transforms. It's not CRDTs. It's something else entirely. And the result is that you can have these kind of longish-lived forks, which are automatically reconciled whenever you come back online. So you don't necessarily need CRDTs for that, which opens up a lot of design possibilities because it means that you're not necessarily tied to YJS or Paratext or whatever if you want that kind of an experience. That's surprising to me. That's not what I thought when we were going into this. I wish somebody had told me that ahead of time. In this example, I think we have tested this. This does work. If you set Prosemir Collab to pull like once a minute or once an hour, you will get approximately the same results as YJS when we put that in front of users. Of course, in our case, users will view it as corrupting their data, but if that's acceptable, if like that kind of reconciliation is fine for your product context, that kind of thing can actually work, I think. Okay, surprise 4, the final surprise. I think one thing that we found that was kind of interesting is that OT and CRDTs are mechanically more complicated, and they do come at sometimes a cost that is not necessarily, that was not obvious to us ahead of time. So one example, my favorite example, comes from this comment from the Prosemir commit collab or Prosemir collab commit repository. Like actually it happened yesterday and it kind of blew my mind, but it's a lot of words, so I'll summarize it. So generally what they're optimizing for is they want the editor to run in 60 frames a second, okay? That means you have 16 milliseconds to apply a remote change per render cycle. Okay, so whatever is happening on the remote server, whatever remote clients, they need to send those changes in such a way that they can be applied in chunks that fit into the 16 millisecond render window. Okay. Now, Prosemir Collab Commit on the server side is actually optimized specifically for that. It sends chunks of 20 steps, 20 steps, like Prosemir steps, basically. And it is roughly optimized so that those 20-step chunks fit into a single render cycle. The application code is super simple. If you go read the library, it is just not that much code. And the lack of mechanical complexity means that it's very operationally predictable. I'm sure that you could get, say, auto merge or something to do stuff like this. The people working on that are super smart, but I don't know how you would do that right now, right? Like we could not do this when we tested CRDTs. It was often the case that, especially for long change sets, it would physically slow down the render cycle of the actual core editor itself. I'm not saying that's bad necessarily for your use case. I'm not saying you shouldn't use these technologies. I'm not saying they're not going to get better. But for us, what we wanted was an editor that felt snappy. Okay, and that was surprising to us when we started this process. So I think my guess is we're out of time at this point. It is a little hard for me to know when I started because everything we had a bunch of technical difficulties, but I have a couple of recommendations for people who are starting the journey of building a rich text editor that is, both collaborative and offline first. A couple of caveats on my recommendations. We're a super small team. If you work at like Microsoft or Google or something, you're going to have different constraints. But for us, our main constraint is that we wanted a single person to be able to own the entire experience from key press to persist. So in particular, that means we want one text editor library that runs both in the browser and on the server. And we want it to have, we don't want to write like a bunch of code around two-phase commit and so on and so forth. Your product experience may be different, but that's what matters to us. And that's where these recommendations are coming from. So if you're in a context that matters, I'm going to wholeheartedly recommend, first of all, React Prosemir, which is, as I said before, a descendant of the New York Times official implementation of their internal, I guess, CRM for reporters. I'm not sure what you would call that. To me, it's a modern marvel of engineering. I think that it's nearly impossible, if you've never worked with an actual text editor before, it's nearly impossible to get Prosemir to work with React. They just have sort of fundamentally different render life cycles. Like, I think almost literally impossible. The way, as I understand, React Prosemir did this was they wrote their own editor view, which sort of makes it possible to bridge these two worlds. I don't know how we would have shipped this without this software. I think it's a modern marvel of engineering. I can't say enough good things about it. For the backend, for commit reconciliation, we use Prosemare Collab Commit. If you want to know how to actually implement this in production, it does require a tiny bit of extra work. I'm happy to talk about that if that's helpful. It's a lot like Prosemare Collab, except it can apply some of the changes on the server when it's reconciling. The last thing is that we use a system called reboot.dev. Reboot.dev is, for our purposes, very nice because it's like like if you're not familiar with Cloudflare durable objects, the nice thing about durable objects is that you give an object a name and then Cloudflare guarantees that there are precisely 0 or 1 copies of that running anywhere on planet Earth, which means that roughly you can write JavaScript as if it was a single server, because it pretty much is a single server. Reboot is a little bit like that, except it obviates the need to do things like do two-phase commit or write to key values, like do this complicated dance where you have to like write to key value store and flush to object storage, because you can sort of, it gives you a state object, right? So if I'm applying a transaction, I have like an apply request, and then I can take the state and I can just set fields on that state object, and then it makes sure to persist that entire object into storage. And then the next time I call apply, I get like a globally unique exclusive access to that state object, and then I mutate the properties on that object or whatever, and it commits. So not not an advertisement for any of these things. I think most of these things are open source. I'm just telling you what worked for us. The last thing is that if you are building like a high performance text editor, I really recommend hiring a specialist, either full time or contracting. This is fairly deep. They didn't ask me to do this. I just think that they're great. There is a shop that does Prosemare consulting called handlewithcare.dev. If that's interesting to you, I highly recommend reaching out to them. But they didn't ask me to do this. This is not an advertisement for that. I just think that they're great. So with that, I think that I'm pretty sure we're out of time. So I'm happy to take questions or talk afterwards.
We'll do Q&A at the end. We're going to move on to Jan. Did you have a question?
Yeah, while Mauve is setting up really quickly, 2 things. You can also hire the author of Prosemare, Marijn, directly. He's an independent contractor and a fantastic person, and he will do anything that you might need him to do. He's a friend from Berlin, where I live.
You can also sponsor them.
Yes, that too.
Yeah, which we do.
And then you said you wish you had people to tell you all of the things that you ran into. If anybody in the audience, or if you ever need any one of those people again, this is what I do for work. This has been my life for the last 15 years. We're just not present enough on the internet, I assume. So yeah, if you ever need help and not find these things out for yourself, I'm happy to talk to you anytime. Just find me here on the Discord. But you don't even have to hire me unless it's going to be a little bit more deeper thing.
That's wonderful. And being able to kind of find the right people is always challenging. So reach out to both. Mauve, I'm unable to open your stream. If you want to jump on the Meet, it's probably either my network or Discord protocol kind of things.
One sec.
So if you stop sharing and join the Meet, I will share from that Meet link.
All right. Should I have my microphone on in both?
Probably one.
One sec. Let me mute it as well. Oh. Okay. I love computers. How's this? Is it working?
Yeah, I am sharing your video, but I don't think you're not sharing your screen on the Meet link yet.
It says presentation is starting. Let me try restarting Google. Or
Today's been especially tough with all the challenges we're facing.
Yeah, I was totally able to share it earlier, so no luck still. A. Oh,
Yep, wonderful.
there we go. Perfect. All right. Excellent. I guess I'll get started then. Hello, everyone. Thank you for your patience. My name is Mauve Signweaver. I'm a decentralized software consultant currently working at Awana Digital on Comapeo. And today I'm going to be talking about how we do peer-to-peer mapping in the Amazon. So I'll talk a bit about how about the app and why we use peer-to-peer in the first place, and then I'll go into how our approach at the data and networking layer works. So Comapeo is used by indigenous groups around the world to document their land. Communities can place markers on maps and attach images or text. This can then be used by communities as evidence against illegal logging or to petition their government regarding land use, and also to just use internally in their communities. Since we're serving people in remote areas, an always online cloud first approach just wouldn't cut it. So we wanted folks to be able to start without needing internet at any step of the process. Folks can start saving data while they're out on their land, and eventually they can meet up with others to either sync directly via mobile hotspots or via more permanent Wi-Fi infrastructure. Our sync protocol also had to be able to handle intermittent connectivity and breaks during the replication process. At the core of our data model are hypercores. They're append-only logs with public keys allowing verification of data and a fancy Merkle tree that allows fast sparse replication using bit fields. We use them to track state in projects, and users create a hypercore to represent the project. Then they assign roles to new members, which get picked up to determine sync and write permissions. And then all of this data is indexed into local SQLite tables, which act as views over raw events. The events themselves are stuff like create, update with unique UUIDs per document. And we technically are a CRDT. It's a last write wins register using wall clocks. But in our case, there's not many conflicts happening in the field anyway, so we don't actually need any fancier CRDT mechanisms. So one important edge case for us is versioning and ensuring backwards and forwards compatibility in the app. We often have folks with mismatching versions out in the field because automatic updates over the internet are just not available. And we needed to account for this from the get-go. For this, we use a combination of the Drizzle or ORM for doing schema migrations and a versioned module of JSON schema and protocol buffer equivalents. Whenever the app needs to migrate to a new version, it'll rebuild its local tables to ensure that any new or removed fields get tracked. In our experience, since SQLite is so fast and since the total amount of data we have is fairly low, this is actually pretty instantaneous on upload. So for security, we make use of capability systems. The on-the-wire protocol uses noise handshakes, which let us know whose public key is on the other side. Projects will share cryptographic keys for new members to be able to participate, and coordinators will add new members cores with restrictions on the kind of data they're allowed to read and write. When a peer tries to replicate with another, they'll only allow the other side to replicate data based on the permissions assigned to them. For example, full members may write their own data, but cannot overwrite the data of others. Peers that know the project keys, but whose role we haven't synced yet, can attempt to replicate just the auth cores, but nothing else. So that once the auth core is synced and we have their permissions updated, then the other data can come after. To maximize code reuse, we're using React Native for our front end and keep the bulk of our peer-to-peer logic inside a Node.js mobile worker that we communicate with over a custom IPC protocol. With this, we can keep our core lean and reuse it across mobile, desktop Electron, and our remote archive servers in the cloud. For connections between peers, we use local TCP servers and defer to the system multicast DNS provider for discovery. We use a random port on appload, but we reuse the port from then on to avoid edge cases like MDNS caching. Once a peer goes online, they announce themselves on the network, and other peers will attempt to connect to them. We deduplicate connections based on the noise public key, and then hand off the connection to HyperCore's replication protocol for checking capabilities and initializing core sync. So that's how the peer-to-peer side works and some of the reasons for why we took the path we did. We're currently refining our desktop app, and in the near future, we've been talking about making project data available to AI via model context protocol. And we're looking to refactor a bunch of our code to make it generally available as a data sovereignty toolkit so that other projects can build upon it. If you're curious to build on top of this stuff or just want to chat, check out our code on GitHub or join us on Discord. And also follow us on Sky. I think I have time for questions. I kind of speed ran it.
Yeah, this was wonderful, and I know a ton of people have questions. I also have a few. So what I'll do now is, as usual, stop the recording and the broadcast,